gonna clean up my pit wall just a little bit because I'm gonna use the same wall I used to do these other measurements for my density measurements because it's nice and shady, but I want to get it flat again, get my little disturbances out of it. I'm going to leave the sticks in there just because I have some reference for different layers there that I can look at. Some fundamentals on this. We got a nice cold day, so this thing's not sticking and filling with ice each time. These things are made out of stainless steel. If you beat on them, they'll dent. Stainless steel is not as strong as you think, and it is quite malleable, so it will bend, so don't bang on them. You can scrape to clean them out with a lid. You can also use a putty knife, which will be in your kit, to clean them out if you got a little bit of ice that's bothering you. You want to keep these things clean because anything that sticks to this will be part of your measurement. You turn the scale on. It's a digital scale, it reads to the nearest gram. You put that on there and you push the tare button or the 0 button, and now it no longer knows the weight of that cutter, and it'll only measure the weight of snow. So you put this in, isolate your sample, you put this back on here, and you'll get a value in grams, and that's grams per liter. This sampler is 1 liter. It's 20 centimeters by 10 centimeters by 10 centimeters, which is 2,000 centimeters cubed, but it's a wedge, so it's only half of that. It gives you 1 liter of snow. The metric system is nice, so this gives you grams per liter or kilograms per meter cubed if you take the gram weight. There's a number written on the back of this cutter. You can check this scale. This is 760. That's 760 grams when you put it on there. The scale's telling me it's 761. That's within the error of the scale. If you're plus or minus about 5 grams, that can just be battery or a little bit of garbage on your cutter, and that means it's fine. If you suspect your scale's not functioning, tare it again, and if it's not weighing about the value that's written on the back of the cutter, then you've got scale problems. There's a backup scale, spring scale in your kits, so you can take a manual measurement without electronics if you get in a bind and your scale's no longer working. I'll go through some methods of how to do this correctly, to make these measurements correctly, and then I'll show you some ways the errors creep into the system as well. So what we typically do for these projects is run 2 profiles. We'd like to have 30 profiles and take the average, but we'll never do that. Again, we're much better off getting several different pits a day than doing one in great detail. But we do take 2 profiles and then we take the average of those. So you basically have an A profile and a B profile in the snowpack. It's not too important how you do that laterally. It is important that you get every 10 centimeters going all the way down the snowpack. Your data book will have 2 columns. One's labeled density A, one's labeled density B. There's a 3rd column if you have an anomaly in there. For instance, if you have one layer that has 373 kilograms per meter cubed and you have another measurement that says 270, those are big differences. If you believe they're both good measurements, then take a 3rd and write that one down too, and that gives us something to sort of judge the variability with. If you think you have a bad measurement and that's the source of the difference, don't write it down. Only write down good measurements. So if you have say a 373 kilograms per meter cubed in one measurement and the next one's 330, that's a pretty big difference. But if you feel like they're both good measurements, stick with that. If you want to do a 3rd one, go ahead, but as long as you're taking good measurements, believe your measurements and believe that the snowpack has that variability. Again, if you think the measurement's bad, don't write it down. Take another measurement. You have a whole pit wall here to deal with, so you can keep taking measurements until you get a good one. Sometimes in a really weak snowpack or a really hard snowpack with ice layers, it's really tough to get a good measurement. It may take you 5 or 6 tries to get a good measurement. Just keep marching across, getting the exact same level in the snowpack to get your measurement that you're after until you get one that you believe in. So what we'll do here is start our A column, and I'll go right in on the surface and I'm going to orient this back plate is what's important here. I want to keep the geometry of the cutter that's taking the sample in exactly the same orientation as this pit wall. So I want to be the same way this direction and the same this direction, so that when I get the cutter all the way in, this back plate is flush against the entire pit face. That's why it's important that you clean this pit up nicely and get a nice flat surface to measure. If you have bumps and anomalies on here, you'll get bad measurements. For instance, if I try and get a measurement right here, no matter how careful I am putting it in, I've got a gap here. I can't push it in until I fill it like that, because I've just compacted all the snow in there and I'll get a bad measurement. So what you want to do is line it up very carefully, and this takes a little bit of practice. See, I can just clean this back out. I don't care about the outside of the cutter for this part of it. I can clean that off until I get a good flat surface, and I'm going to go in here and I'm going to line it up, and I'm going to go right in, skimming the surface here. I'm going to very carefully line the cutter up, pull it out, take it off. I've got a very little piece that's gone there. I'm not going to worry about that. I am now going to clean the outside of the cutter off, and then I'm going to weigh it and get my gram weight. Okay? That's just a demonstration. These scales have an automatic shut off with time. You'll find that pretty quick you get fast enough that that thing won't turn off on you. So let's take another one. That would be my column A. Let's take another one over here. Very carefully lined up. Slide that lid in, pull it out, clean it off. You can see I got a nice layer, nice measurement there. 140 grams, that's 140 kilograms per meter cubed. I would record that in column B. I had column A and column B. Then I go to the next layer. Now that was 169. I also write down both the top and the bottom depth of each measurement in the first two columns, or the first column of there with a dash in it in the field book. So that's 169 to 159. The next measurement will be 159 to 149. I'll come right in here, do the same thing. Carefully line it up, nice clean cut. Make sure there's nothing on the bottom or the sides. Got a little bit of snow right there. I want to get off. 186 grams. That's 186 kilograms per meter cubed. That goes in column A. I'll come in here and do my column B right next to it. Nice clean sample. 178 grams. See a little bit of variability there? A couple of grams. Go back to column A. Now I'm at 149 to 139. $206. A little denser. Come in here to column B. $213, 5 gram difference. Okay, ad nauseum right down the snowpack. I'm referencing my tape measure over here. Be 139 to 129. Little bit of loss there, not significant. 244, a little denser yet as we get into the snowpack. Each time I'm making sure that the cutter's clean before I go back in. You can see you can get quite speedy at this. 247 grams per meter, or grams per liter. So I've stepped this down back and forth, and I'm trying to go all the way to the base. You can do this in several different ways. You can put both next to each other and jump over here like this back and forth, or you can do like I did and go back and forth. Doesn't matter. We're going to take the average of each of these layers. And we're looking for a little bit of spatial variability here to look at what the snowpack's actually doing. Let me show you some ways now that you can get a bad measurement and what to do about that. Basically, if you get a bad measurement, you're going to throw it out. You're not going to keep it. So problems come from not getting this quite lined up right. You get in here and you find, okay, the back of my cutter is flush with the snowpack here now, but I still have a big air gap here. I can't fix that. I got to throw this measurement out. So if I just put my cutter lid in and pull this out, you can see the problem there. I've got a big gap in that. That's going to be a big anomaly in the density measurement. So I'm going to throw that out and I'm going to go over next to it and do the exact same measurement again and hopefully get it right. Okay, I'll show you another thing that happens. I'm still not lined up quite right. Now I've got the heel of the cutter here is not flush with the wall, but the top is. So if I take that sample out, it looks good on the surface, looks like a perfect measurement, but it's not. I've got a big gap inside here in the heel. I don't know if I can show you that. If I pull it out, you can see that's a different angle. So there was a big void in there that will cause me a problem. So what people like to do is get all the way in here and they see I'm flush on the back, but I'm not here yet. So I would just shove it in. Now I've got a full sampler, right? I could go ahead and sample it. But I've got a increased density there. I don't want that sample. I've oversampled the snowpack in that case. So don't be tempted to do that. Another common mistake is to start in and you realize as you get a little closer, I'm not lined up, it's not going to come out well. You can see this is not going to be a good measurement. So I adjust the cutter as I'm going in to get it lined up flat. I've compromised that sample. I've changed the structure of the snowpack in there and I'm either going to oversample or undersample doing that. Throw that measurement out. So here's another one. I'll do a measurement. I get a perfect sample, pull it out, weigh it. I do another one next to it. And it looks perfect, but I got that void in there and it's 30 grams less. And I look in there, I see a little bit of a void. I don't write that one down. I throw it out, clean out my cutter, come in here and get another measurement. Another really common mistake in high density snow is to get the lid oriented wrong and you won't feel this as you put it in, but you pull it out and you've oversampled this direction. You can't come in and shave that off like this because you'll get a bad measurement. One, you've got a void there, but I've probably compromised the sample in other ways. Just go ahead and take another sample. Let me do a more reasonable version of that that's more typical. You can see I've oversampled that. Don't be tempted to do this because almost always what will happen is right at the end you'll chip a piece off and you'll miss part of your sample. Just take another one. And you can't pull the lid back out and send it in again either because you'll also compromise that sample. If you got a bad measurement or if it's going south, just go ahead and change it and do it again to get a good sample. One way to guard against that is to start your cutter in a little steeper than the angle of that cutter body itself, and it'll force itself to come in flat and you'll get a perfect measurement every time. It's really hard in big depth ore that's really weak to get a good measurement with this system. What you have to do when you're down in this really weak stuff is very carefully get your cutter in there and hold the cutter with your hand very still. Line this up, and a lot of times what you'll need to do is move that really quickly going in before the snow can fall. And this stuff isn't too bad, but a lot of times what you'll see in that really weak snow is you'll pull it out and your sample will look like this, like you didn't get it. But what's actually happened is this really weak depth ore is just falling apart. And as you put in that cutter, it destroyed the structure of it. It captured it all, but it just fell into the bottom of the cutter. And as long as you pull the whole system out, turn it flat and go like this, you've still got a good sample. You still have all the snow in it. But you just, it just looks like you've got a lousy sample. So that takes some experience, but probably the hardest stuff to measure is wet depth or in the spring. And you may be sampling in that condition. You most certainly will in some of the experiments and some of the sites. There, speed is the key. Get this in very carefully without disturbing the snowpack. Line up your cutter lid just right and move it in really quickly, and you'll pick up a sample. We have another cutter that we use, and this is often valuable in places with a lot of vegetation where you can't get the whole big sampler in around tree bushes or something else. Sometimes this works in really weak depth hoar too, when you can't get a sample with a big one. And this one works exactly the same way as the bigger one. Got to keep it clean. You can tear it just like you did the other one. You put it in, smaller lid, sample, same thing. This one's 250 cc's, so you have to multiply your gram weight by 4 to get the 1000 cc sample. You probably don't want to do that in the field. You want to put a little asterisk by your sample, and then in the note say you're using the 250 cc sampler. Write down your actual gram weight, like 47 grams, and then back in the lab at night or in the hotel, wherever you're staying, you can fix that and do your multiplication when you're warm and not cold, and you won't make a mistake. When you're sampling right at the ground interface, so I've got 169 here, that means I'm going to go 169 to 159, 159 to 149, all the way down in tens. So my last full sample will be 19 to 9. I can't take a 9 to 0 because the dimensions of this sampler and this sampler on the back plate are 10 centimeters. So the best I can do is a 10 to 0. You're very seldom going to be able to do a 10 to 0 because of ground roughness. So do the best you can and write down what you actually sample. A lot of times you'll be doing an 11 to a 1 or a 12 to 2 or a 13 to 3, something like that. Just write that down instead of the 9 to 0, which is ridiculous, or the 10 to 0, which is rare. You pretty much have to be in a parking lot to get the 10 to 0 or a sidewalk, and you're not going to be in those situations. So if you've got any ground roughness at all, you'll probably be an 11 to 1 or a 12 to 2 or something for that bottom set of measurements. But write down what you actually do, and then we'll take that into account when we calculate the whole density profile. Don't be tempted to go in this way. It's easier to hold the sample in, and people do this. The problem with that is any kind of anomaly you have in the snowpack. Say this was a dense layer and it was covered by a less dense layer. If I sample that layer in this bottom, I oversample the dense layer and I undersample the less dense layer. If I go in this way, I get the same volume cross-section of all the different layers. So always orient your cutter sideways like this. It seems like more of a pain to do it that way, but you get a more accurate measurement. Another thing to be careful of when you're measuring is that you just want this back plate flush with the snowpack. If it's all the way in, so that the surface here is flush with the snow, then you've oversampled. You've pushed it in too far. So don't be tempted to get it in here flat and tap it like this. You see that happens sometimes. Now I've oversampled that. I haven't made much difference, but I've biased the sample a little bit, and I've got a little bit denser snow than I wanted there, right at the back. So the reason that we do this staggered sample this way and that back and forth is that the inside dimensions of this sampler are 10 centimeters, but you have some wall thickness here, and when you shove that in, it disturbs the snow on both sides. It has a beveled edge so that it only samples the 10 centimeters and it pushes everything else to the side. So when I go in here, I've compressed the snow a little bit top and bottom, and this is a little bit wider than 10 centimeters outside. So if I take this sample, and it's a good measurement, And I weigh that, take the density of it, come back and take my next one, and I come in right on top of it. There's two problems that are going to happen here. I've got to line it up just perfectly to go in there, but there's probably some snow that's fallen on that bottom edge from the last sample, and I'm measuring snow that's been compressed a little bit. The only time I recommend doing this is if you're dealing with fern or very high density, like in a wind pack or on a glacier accumulation area. Sometimes every sample is so hard to get that it's hard to go back and forth staggering, and if you're very careful, you can do a continuous profile like this. We don't want you to do that for this seasonal snow stuff. So the idea of going back and forth is that each sample doing this is independent and it's not compromised on the top and bottom. You get a good clean sample each time. Be cautious of using this smaller sampler if you don't have to. This sampler is a little bit bigger. It's 4 times as big actually, so the surface to volume ratio is different. It's a little less prone to error. Some people feel like it's cumbersome because it's bigger and they can take a better measurement with this one, with a smaller one. But if you're careful and you practice, you'll find pretty quickly that you can take a good measurement every time with this big one as well. So we prefer that you use this one anytime you can for this NASA work. These are also a little bit stronger. If you get into an ice lens or a strong crust, you can actually tap these back corners on this one with a rubber mallet. You'll have a rubber mallet in your toolkit too. Do not hit the handle and don't hit these top edges. These welds will break. It's stainless steel and it's relatively soft. You can tap this handle a little bit, but if you really need to get this in a hard layer, hold it by the handle and tap this, either one of these corners, to get it in and get it as flat as you can to get a good sample. Sometimes in the Sierra, for instance, you'll get an inch-thick ice lens. If you try and beat this in to inch-thick ice lens, you'll destroy the sampler. So don't do that. You'll need it for the rest of the trip and the rest of the season. This sampler will cut ice lenses that are not too thick, and you can sample those, and the lid will as well. Sometimes the lid is the hardest part to get in, really dense snow. You'll need to hold this in when you're pushing in that case, because the lid going in will try and pop this back out. So keep a hand on this part, and once you get this in, you can start to hit this with your hand and it'll drive it in. Again, you can use a rubber hammer on the back of this lid too. Then very carefully pull both out at the same time to get a good sample. If you pull this out by itself, you'll often lose some of the sample. Obviously, you don't want to pull out the lid first. You can also change the orientation of this sampler if you want and go in this way. That doesn't matter. You can go right or left, depending on what works better for you for the geometry of your eye, or if you're right-handed or left-handed. Either way, I've found this works better for me, but I know lots of people that go the other direction. In no case should you hit this one with a rubber hammer. You'll destroy this one. It's much thinner gauge metal, and that's why in really dense snow or any kind of ice lenses or anything else, you want to use the big one. You'll bend this right away. As soon as you bend it, you'll compromise the sample volume, and then you'll compromise the sample. So don't hit that one with anything except your hand to tap it in. The other place you'll find difficult to measure in the spring is when you get the preferential flow fingers or tubes of ice that are refrozen from water percolating into the snowpack. And those can be really frustrating to measure. You'll shove this in, and all of a sudden the cutter will get pushed to the side in weak, wet snow, and it's hitting one of those columns that's pushing it to the side as it goes in. You just got to keep trying until you get a good sample in that case. And there's no simple way to do that. Good luck. But don't take, again, if it's a bad sample, don't write it down and keep trying until you get a good sample, or write an NA and a note that you couldn't sample that layer. If you get sticks or bushes in here, try not to sample those. A few pine needles will make no difference. Anything bigger than that, you'll want to watch out for. If you have some anomaly that's like a buried snowmobile track or a ski track, go ahead and sample it. The remote sensing instruments are seeing that too, and that's what we're after. We're trying not to measure things that are compromising the snow properties in terms of like a different density, like a tree branch or a dead animal or something, but certainly anything that's in the snowpack is what the remote sensing tools see, and tracks are part of the game nowadays in the backcountry, everywhere. Oftentimes the biggest differences in the snowpack are right at the base of the snowpack. Sometimes you'll have an ice lens down there that you won't be able to sample. Record the thickness of that lens and the properties of it, if it's a clear ice lens or a bubbly one, and then we can assume a certain density when we're calculating the total snow water equivalence for that profile. If it's something to do with roughness, like a bush, do your best to get a good sample in there somewhere. Use the smaller 250cc cutter to get one sample out of there if you can. There will be a number of times where you can't get two good samples at the base of the snowpack because of surface roughness or vegetation or scree or some other anomaly at the bottom of the snowpack. Get what you can. Try and get at least one good measurement as close to the bottom as you can, but oftentimes you may not get two. Do the best that you can. If there's a bush or something there, in this case, in this snowpack, I ended up hitting a couple of trees even though I probed for it, and I got enough space down at the bottom of the snowpack to still be able to make measurements. You can move those measurements around at the bottom of the snowpack. I often find that right where I've done my profile all the way to the base, I'll have problems getting a good measurement at the base itself, and I'll just move around the bottom of the pit wall until I do get a place that I can sample that. It doesn't matter, the density at the bottom of the snowpack is probably going to be very close to the same everywhere, and just because I've moved over 20 or 30 or even 100 centimeters from where the rest of my snow measurements were doesn't mean I've got a bad measurement, or doesn't mean it's going to be a problem. It's better to get a measurement, a good measurement down there, even if it's in a different place than no measurement at all. If you're on a slope that's significant and your shaded wall is at the top of the slope, it's okay to take some of your measurements for a particular layer, particularly the top and the bottom one, out of your flank of your wall. And then you can orient your sampler to the slope and get a really good measurement. So if this is my pit wall on a slope and this is my shaded wall that I'm taking all my measurements in, I'm going to get a funny measurement at the top, trying to do the density here if I'm going down this whole wall. If I'm trying to get a total column, I don't really care about the differences in the wall, but I might want this surface layer very specifically. So it's okay to do two different things in that case. If I'm clicking all the way down this pit wall for my staggered measurements for my column A and B, I probably don't want to come in here and measure this way for the first measurement, because I'm missing this snow here. So there's two things I would do. One is to come over to your flank and come in here and get your surface measurement, just like that, and do two of those over there, and then do the rest of your measurements down the pit wall here, and you still got a little bit of an anomaly there that you're missing, but that's better than just starting your whole series of measurements this way. The other thing you can do is come in here and make a perpendicular surface for that first measurement and go right up slope at your location there and grab your sample. And that'll take care of your slope problem. You'll have to do the same thing at the base of the snowpack if you're on a slope and you try and do that bottom 10 centimeters or the 11 to 1 centimeter measurement, you'll be going right into soil or dirt or whatever you have at the base of the snowpack. So you'll have to orient your cutter like this to follow the slope. So either come in with your shovel or the cutter lid and cut that vertically or plumb to the slope rather than plumb to the center of the earth, and take your sample that way, or go over to your flank of your pit wall and match your slope and go in horizontally this way to get the measurement. Be sure to check your data book again. Make sure that all your header information is filled out. Make sure that all your column data is filled out as far as it's appropriate. All your stratigraphy, your snow wetness, everything like that. Make sure you've filled out the comments that are relevant. Your metadata sheet, the same thing. All the stuff about the site and the weather and the wind and the ground condition. Make sure you got all those. There's also a checklist here, and you should be putting a check in every one of these boxes. If you put a check in there, that means you actually thought about it and actually did it. If you haven't checked it, it means that you haven't done it. So don't get in the habit of just checking all the boxes when you finish without reading them. So I'm going to go through this. Metadata and headers. I'm checking all those boxes to see that they're filled out. Then I'm going to check this off. Weather obs, check. Grain size measurements, check. Grain type measurements, check. Soil moisture observations. We'll talk about that separately in separate training because we won't do that at all sites at all times. Vegetation observations, ground observations, temperature profile, density profile, the wetness profile, hand hardness profile. So one of the really important parts of this exercise and data collection is photo documentation. Every group will have a camera, and we will want you to use these cameras. You can take pictures with your iPhones and whatnot as well, but that's hard to get those data from you necessarily. When you use these cameras, we'll get the chip or the card out of it every night and download the pictures and label them and everything else. So there's a couple of protocols that are really important for those pictures to be useful. Anytime you shoot a picture, we want to know where it is. It doesn't make sense to record the picture numbers and the camera number and all that. It's too complicated. We've tried that and we've failed at it. So our policy, and what works really well, it's a little bit of more work at the back end, but it works really well in the field, is for you to shoot a picture of the header of the site as your first picture of anything you do. And then any specific measurement that you make in the snow pit, you'll take another picture of the header that details that. Now let me give you an example. When you come on the site, the first thing you'll do, you'll be working in pairs, and one person will fill out that header information on the site while the other person starts to dig after you've picked your site and you've probed it and you know this is the site you're going to use. So the person who's doing the documentation will pull out this camera, and the first thing they'll do is shoot a picture of this header information that's filled in, a close-up. All they got to do is get the pit, site, date, location, and that information. It doesn't matter about any of this other stuff at the bottom. Then our policy is that we know every picture after that until they see a new header is from that pit. And that really makes it easy for us to document where these pictures are actually taken and keep them attached to the data that's appropriate. So there's another protocol that we have for the site. We want to know what the sites look like. We want, especially on the time series sites where we come back time after time, we want to see how the site changes through the winter. So as soon as you approach the site, as soon as you take that picture, you've got your compass out because you're filling out the aspect of the site as well. You'll know which direction is north, east, south, and west. You'll take 5 pictures of the site from the place that you're digging the pit. And this will be the data person that's doing this. And it doesn't matter exactly where they're standing, but it'll be close to the pit location itself. And the first picture you take is of the header. The next one of the series of 5 in a row is one to the north direction. And then you'll go clockwise. East, 90 degrees, south, 90 degrees, and west, 90 degrees. And then you'll pop the camera up and shoot one of the canopy. And it doesn't matter if there's no canopy. If you just have blue sky, that's what we want to know. Just get your camera level and relatively low. You don't want your face in it, but relatively low so you get a good expression of the canopy, and shoot that picture, and that'll show the relative influence of the site due to large trees and whatnot. Okay, so you'll have those 6 pictures for every site. If you take no other picture, you'll have 6 pictures for each site, the header and then the 5 views of the site itself. But we want you to take other pictures. As soon as the pit is excavated, that ship has already sailed on this one, but as soon as you have a nice clean pit wall, and sometime between when you've cleaned it off and you got your instruments in place and whatnot, and maybe even with the stratigraphy in here, shoot a picture of the pit wall. And if you have to shoot several to get the whole area, or if you have a anomaly in there you want to do a close-up, do all of those, and those will follow the 5 site pictures of the 4 cardinal directions and the overview as well, the canopy shot. And that also characterizes the site. It's really good to get a picture of the ground too. Like in this pit where I had 2 trees in the bottom of the snow pit, I want to document that, and that should be in my notes on the pit as well. But I want to photo document that as well. Another thing we'd like you to do is take pictures of individual layers. Like this surface layer has very fine-grained small snow, and I can take a really good picture with these small cameras that you'll have on the macro focus mode just by holding the camera like this and shooting the picture. Before I do that, I want to know what layer that came from. So before I do any measurement like that, what I'll do, since I have my stratigraphy already recorded in here, I'll point my pencil or some kind of marker like this, one of the markers from the stratigraphy, and I'll shoot a picture of that. Then I know that all the pictures that I shoot of the grains following that are that specific layer that it's pointing at. So I'll do that, then I'll take my sample, I'll tap it. I want to spread it out enough that I can see the grid, because if I just have a blob of white, it looks like a blob of white. But if I spread the grains out individually, then I can shoot a picture of them. I might shoot 4 or 5 of those, different places. I might take several samples from that layer. I know that all those pictures came from that layer. When I go to my next layer down here, I move my tongue depressor or coffee stirrer or pencil down to the next layer I'm going to shoot a picture of, and I shoot another picture of that. I know then that all the pictures are shooting of that, following that, or of that layer. So I'm really interested in this big depth ore layer down here with these massive crystals. Make sure I shoot it on the end of the card that has the grid on it, spread them out, and I again shoot a bunch of, or 1 or 2 or 6. There's some cool grains here. I might shoot 7 of them, and I can kind of balance this card. I can put it on a shovel and hold the camera steadier that way and shoot the pictures. Helps to look at them and make sure that they're coming out. These cameras all pretty much beep once they're focused. Be careful not to just be shooting them before they beep, or you'll get a bunch of pictures of fuzzy grains that don't do us any good. If you want to shoot pictures of the day between your transportation, something interesting in the snow pit, do some other method of recording that. Write down on a piece of paper that this was halfway between site 36 and site 37, something like that. You can just shoot a picture of your GPS screen to record where that site was for a picture, something that was important or that you thought should be recorded. We do want some kind of attachment for location and a time to everything you do in terms of the photographs, and that'll help. The cameras will have the time in them, of course, but the location is something you'll have to add. Once you get to the next pit, you'll start again with the header, and we'll have a new set of pictures, and that'll be recorded in the same sequence. When you finish with the pit, make sure that you have all your equipment back in their respective places. The scale is important to keep relatively dry. These scales are made for laboratories, not for the field, but the best ones we've found, they actually have a negative temperature rating. They seem to work well below the temperature rating, but they do have a lid, and they do have load cells in here, and they do have a crack that lets moisture in there. Try not to let any snow get in there. This is the one thing you really want to keep dry. So don't pull this lid off like I just did. Leave the lid on and keep this thing as close as you can to dry. Keep it in the case when you're not using it, and brush it off if it's snowing regularly, and blow it off. Make sure you get all the snow out of the cracks before you put it back in the case for transportation. We will take these back each night and dry them out and change batteries if we need to. There'll be spare batteries in every kit if the battery fails on you out there in the field. There'll be a backup spring scale in case you can't use this anymore if it really breaks, so that you can still get measurements of density. These load cells are sensitive. Don't overload this in any way. That's why we carry them in a hard plastic case. Don't just shove this in your pack and let it get beat up. Put it back in the case. Each one of these cases is set up with your equipment. They're configured different ways, but there'll be 2 thermometers, there'll be 2 rulers, 2 folding rulers in there. There'll be some of the coffee stirrers to mark your stratigraphy. There'll be a spare battery spare batteries for the scale, and maybe some other items. There'll be a backup spring scale, which I'll show you in a second. And there'll be some plastic bags. Make sure all that stuff's back in the kit before you leave, and your thermometer should already be back in the kit as soon as you finish your temperature profile, so that you don't lose it or step on that. Put that stuff away, put your cutters back in your cutter cases, and put everything back in your pack. Get everything out of the pit, and then we do backfill our pits. A lot of the places we work are used by recreationists, and for safety purposes we backfill these pits so that somebody doesn't auger in with a snowmobile, or if it's a backcountry area where they're skiing and or snowboarding or other recreational sports, we don't want people falling in these holes. So at a minimum, throw enough snow back in here so that it's a minor divot. It doesn't have to be perfect, but it can't be a tiger pit. If you do have this kind of dirty snow that's going to cause a change in the melt, and it's a site that's going to be used multiple times, seek that out. If some of it got thrown out of the pit, try and get that back in the bottom of the pit first. If you have a failure of your digital scale, there is a opportunity that you have to still get a density measurement, and I'll show you how that's done. We have a separate spring scale, no electronics, that works in almost all conditions. And you can hang that, and you can take a Ziploc bag and it's a little more tedious and slow, certainly, than the digital scale, but it works just the same. It will give you a measurement. You put the bag on the scale. One problem is this doesn't work very well in really windy conditions. Put the bag on there. You can adjust the tare on the scale by turning this little knob on the top, and the line on the barrel that moves should line up with the 0 there. The other thing you can't do is hold this tube like this in any way when you're trying to weigh, because it has to hang freely or that will bind in there. So if you hold it anywhere up here by the loop, you're fine. So I got a 0 there. I'm going to go ahead and take this sample and just demonstrate the method of that. Clean this out. If I get a good density sample here. And you can see this is more tedious than the get the rest of that loose stuff in there. Got my full sample, and then I can measure this in grams again. This scale is, there'll be different scales depending on which cutter you use. You'll probably have a 600 gram scale, and it'll have 5 gram increments, and you'll measure that. And depending on which cutter you use, it's the same exact thing as the other system. I use the 250cc cutter, so I'd multiply my gram measurement there by 4 to get kilograms per meter cubed. But I'd just write down this gram measurement and the 250cc cutter for this example in the book. Okay, So that's going to be slower. If you're doing that, you're probably only going to do one profile rather than two because it's significantly slower than the digital scale. But this will get you by if your scale fails. Okay? When you go to your next measurement, make sure you get this bag dumped out well, and all you got to do is check your tear and make sure it's 0. If you got a little bit of snow in there and you have to re-tear it, that won't matter because you've zeroed that out again. Okay? You get a little bit of snow in there, and if it's wet and sticky in the spring, it'll be hard to get it all out, but just re-tear it and then you can use that. It's a little bit more of a pain to do it with a large volume cutter because you have to get more snow in the bag, but it works just fine too. If it's a site that you're using multiple times in the time series sites that we'll use, it helps to have a marker to put in and put it in 1 meter or arm's length away from your farthest pit extent on your wall. And then when you come back in 2 weeks to do your next measurement, you'll advance past that site and you won't have to try and figure out where that was. Most of your kits will be set up somewhat similar to this. They'll be in a Pelican case to protect the equipment. You'll be issued a set of equipment every morning. You'll get one of these cases, you'll get a shovel, you'll get a probe set, you'll get a bag with other things, communication equipment, some of the other tools that won't fit in here like a rubber hammer and some of the walkie-talkies and things like that, depending on your location and the local protocol. But this kit will be set up with a space underneath, and in that space you'll have a folding rule, you'll have a spare scale that works when you don't have a digital scale working anymore, your coffee stirrers, spare batteries for the scale, things like that will be in there. And the kits that you guys will actually have will have more equipment than I have in this one. And your thermometer will be on the base there too. This is a different configuration. Thermometer goes in here. You'll have 2 of those in the base there. And then this scale goes on top. When you put the scale in here, again, make sure that there's no snow on there, because if it melts in there and then goes in there, it goes in the internal guts of this thing. The electronics really don't like water, and that's when you will get a failure in the field. So make sure that's snow-free, put it back in here. And when you close this, make sure there's nothing on top of this load cell, on the top of this table when you close it, or it could damage the load cells and give you bad measurements from here on out. You can also stick your crystal card in the back here, or you can put it flat on this part of the case, but don't put it on top of the load cells. The other thing that you will have in here is your putty knife and that kind of stuff, and it should all fit in there. Be careful with it, make sure it's clean and dry, close it up for transportation, and move on. Your bag, your other equipment bag will have your macroscope and your camera in a case and paintbrush and all that kind of stuff. The plastic bags can go in the bag or in the case as you wish. When you leave the site, put the cutters back in. They don't have to be dry, but it helps if you clean them off, and then you get less liquid water in there that's going to freeze the next time you use it. So try and clean those up a little bit. And then those go back in your pack. That scale goes in inverted with the cutter upside down. This scale goes in lid first like this, and then because of the difference in the handle, it goes in base first. If you try and cram it in the other way, it may fit, but it may not. Some of them do, so you can do it either way. And put that back in your pack too. Make sure you've got everything out of the pit before you start backfilling, and then you're off to your next site. So one of the things that you'll have to decide when you first get to your site, and this is one reason for probing, is how big to make your pit. I made this one huge because of the video and because I found a log in the bottom and had to make it bigger to get to a place that I could sample. But one of the things that you need to do to optimize your effort is to pick an appropriate hole size. And if you've got a 1 meter snowpack, if that's all it is, you can get away with a much smaller hole than you can if you got a deep one. So general rule, if it's 50 centimeters or shallower, I just scrape out enough to be able to get the cutters in and make the measurements, and I often even lie down or get on my knees to make the measurements. If I'm a meter deep or so, then I'll carve out a hole that's about a meter wide this way off the pit that I'm measuring, and maybe 1.5 meters this way, just so I have room to move. The big thing about the size of the pit is it's really hard to get snow out of a small hole if it's too deep. You're cramped, and a lot of the snow comes right back in, and you'll not be able to use your shovel effectively. You're a lot faster if you have room to move with the shovel extended and can really move some snow by really throwing it. So you're better off starting with a bigger area on the surface. If I'm 1.5 meters, I'll go about 1.5 meters by 1.5 meters at the surface. If I'm 2 meters deep, I'll go 1.5 meters by 1.5 meters as well, but I'll leave a step in the bottom of one end if I'm having trouble reaching for the upper measurement, especially if you're not 6 feet tall. It helps to have a step in there. If you have to put a step in and you're standing, say, 30 centimeters or 1 meter off the bottom here, and you're making measurements here in front of you where you can reach it, just follows a line in the stratigraphy over when you've sampled this section and get to that same line, move your ruler over and continue your measurements to the bottom. So you have all your density measurements in your stratigraphy here, and you'll go to a reasonable height here. It doesn't do you any good to be bending over making difficult measurements at the bottom of this part when you can stand on the ground over here and do them. So just transfer everything over here, move your probe, go to the ground in both places, but look at a layer that's obvious, that's say 70 centimeters off the ground. Move your probe over here, and that's where you'll start your measurements and go to the bottom. If there isn't an obvious change in the stratigraphy that you can follow, try and do it by depth. And if you go to 70 off the ground over here, start at 70 off the ground over here in a homogeneous snowpack and continue to the bottom. If you've got a really deep snowpack, if it's 3 meters or more, you may even need to do 2 steps in there. And you'll probably need help digging it too. At that point, your partner will not be just sitting there collecting notes while you dig. You'll be throwing snow up on one of the steps, and that person will be throwing the rest of the way out to get your pit dug. Hopefully you won't have many pits that deep. It takes a couple of days to do a 7-meter pit because you have to dig such a large area to get all the snow out. And those aren't too valuable for the kind of work we're doing. You may end up doing some of those in the Sierra or maritime snowpacks, as we have in the past. But a 2-meter pit will take about 2 hours to sample completely with all measurements and everything done at high quality. If it's taking you longer but you're getting good measurements, that's okay. Don't try and go fast to do them quicker than that. It's not a race. You can do a pit an hour if they're around 1 meter. It depends on the conditions. It depends on how easy the sampling is and that kind of stuff. So just to give you a ballpark, for most of the sites in Colorado, we should be able to do between 2 and 4 pits a day. If it's really easy conditions and you have a lot of experience, you can up those numbers to 4 to 8 pits a day. But again, it's not a race. We're trying to get good data. But you should be able to get more than 1 pit a day. I guess on the surface area thing, I do want to emphasize that when you start digging on the surface, when you make your lines on the pit walls and where you're going to throw all the snow, don't compromise that surface. You'll need that for your measurements. And start your full excavation at that size that you want at the bottom. Don't dig yourself into a hole and then have trouble moving snow out. Go ahead and just work layer by layer down a foot or so at a time till you get to the ground at your total footprint, and you'll be much more efficient than you will if you try and dig deep and then you realize you don't have room to move, so you have to make the pit bigger. Just start big, and pretty soon you'll have a feel for how big to make these things at the outset. It really helps to do this depth probe and know what you're going to be digging as a total depth before you start, because that way you can pick your size.
Cutter, minus that as possible.
That's what you're after.
Okay, hold it there for a sec. Keep holding it there. I'll turn it to the side even, maybe. Okay. Yeah.
You can see the stratigraphy in there a little bit. I don't know if it'll pick up or not.
Hold on a sec.
It's pretty cool. You can see a little anomaly right there and another one there. Kind of like a layered cake.
Yep, exactly.
It's really neat. This is a pretty boring snowpack. It's pretty much the same all the way down, except they never have.
You should do that at someone's birthday party. I mean,
At a wedding, you know?
that would be pretty amazing.
I've
to get
carved
the
a pumpkin
profile-
with the chainsaw on Halloween. That's as close as I've gotten. That's
Well,
funny.
let's make a video sometime of you, like a funny video of you cutting a cake and talking about kind of the science behind like how to
That'd
do
be
it
great
properly.
with that one.
Especially for your tool, because you made that.
Well, as avalanche instructors, all the time we talk about the layered cakes, you know. And
That would be so funny. You could make cakes with like
Yeah.
all the different examples of layer types.
that'd be really fun. Let's do it this summer.
That would be a cool thing to do.
Big German chocolate cake or something.
Yeah.
With multiple layers.
With like a nice like coconut layer in there.
Let's see what else I can do. That one has multiple problems.
Right.
You can go in all the way so it's settled inside. Oops.
Ooh, that's a real bad one.
Amateur.
Oops. Not gonna work. Didn't go in far enough with the lid, so I didn't capture it all. So the things we want you to take away from this are general commitment to good measurements, recording those effectively so that we can use the data later for many purposes for many years, and safety. So safety first, good quality second, good quality data second, and good recording. And then if you choose to use the data, good science with the data. Have fun at this. There's a lot of neat information you'll get out of every snow pit. There's incredible things going on in the snow pit. It's sometimes hard in these projects where we're trying to collect a lot of data to stop and smell the flowers, if you will, or look at the crystals. I encourage you to do that. You'll learn a lot in every snow pit. I still learn something in every snow pit I do. You've got to be efficient and you've got to collect data and not go down rabbit holes. But do enjoy yourself and listen to what the snowpack's telling you. There's all kinds of neat stuff happening from the ground to the surface and beyond. And I hope you enjoy this. If you have questions, there's lots of good people to ask about these various techniques and applications. And thanks for your work on this project, and thanks for viewing this. And I hope you learned something and this was instructional.